We're at question 4a. So now it says a waveform of the type y equal a sine bx plus c then plus d has a horizontal phase shift of 1.5, a period of 5, and an offset of 2 and an amplitude of 3. Must calculate the values of a, b, c, and d. Alright. Now, let's see what's going on here. The sine wave. Let's look at a graph plotter with GeoGebra. And we're going to plot a sine wave and make some modification. So this is y equals sine open bracket x close bracket. Alright, this is our sine wave. Let me make some modifications to the appearance of it. Make it thicker. Alright, so f of x equals sine x is what it calls it. Let me zoom in a bit. Now, as you see, the period is 3 point something. It's pi. I mean 2 pi. From here to here, it's 2 pi. Which is 2 by 3.14 something. So you see 5, 6 is a little above 6. Alright? Suppose we make a little modification to it. After we close the bracket, we put plus 1. Enter. You see this line was at 1 and it goes up by 1. Let's take the 1 off and goes back to it. Suppose we have y equal and the sine of open bracket x close bracket plus 1. We have our new sine wave. I'm going to make some modification to this new sine wave. The color, let's make the color of the modified sine wave red. And we want it to be thick. I want to show the formula on it as well. So here, what we have, the original sine equal, the original sine x is this. When we add 1 outside the bracket, it goes up, right, by 1. Suppose we modify it and put minus 1 then. Y equals sine x, close bracket, minus 1. It goes down by 1. So, alright, so as you can see, there's an offset to it. After you close the bracket, what you put outside of it is the offset. So D, right, is the offset. So in this case, D is whatever the offset is. And in this case, it is equal to 2. Alright? Now, let's go back to it. Let me make some changes to the modified sine wave, the red one. I'm going to put 2 sine x. Oh. So here, the amplitude changes. Originally it was 1, now I put 2 sine x, so the modified sine wave is too high. So the amplitude would be whatever multiply sine x. So, and suppose For argument's sake, I put 0.5 sine x. 0.5 sine x is half the amplitude. It goes to 0.5. Alright? So A sine x. A is equal to the amplitude. In this case, A is equal to, it says amplitude of 3. Alright? So this part shows the amplitude, the A. Let's go inside the bracket and see the number that multiplies x. Now let us put this back to what it was before and say the number that multiplies x, 2x. Oh, I don't want to modify the black one. Is the red one that I want to modify. Let me do a little adjustment here. Let's put the black one back to the original form. I want it to remain in its original form, y equals sine x, or f of x equals sine x. Now, let's put y equal 2x to the modified one. Oh, when you say 2x, the frequency is twice now. Notice the frequency of the original, the black sine wave was 2 pi, 6 point something. But the frequency of the modified one, the red one, is twice. Because we go through one cycle of the red and 2 cycles of the red to match 1 cycle of the black. So in this case, what we do when we put 2 sine 2x, we double the frequency. So the frequency is whatever multiplies the x inside the sine, inside of the sine. Let me see something. Suppose I put 0.5x. Aha. In this case, the frequency would be, or the wavelength would be twice the original. The black sine wave, the wavelength went up to 2 pi, but when we put 0.5x for the modified, the red wave, the wavelength went out to 12 point something, twice the wavelength, so half the frequency. So 0.5 gives us half the frequency. 0.5x gives us half the frequency. 2x gives us twice the frequency. So in this case, what we have is that the original wave, the frequency, the wavelength was 2 pi. But modified wave with 2x, the wavelength is pi, which is twice the frequency of a 2 pi wavelength. So here, the dx, d is the frequency, right? He didn't ask for any frequency, but b would be the frequency. B equals frequency. He didn't ask for a value of the frequency, but we know whatever multiplies b would be the frequency. Alright. Now, we went outside the bracket and found sine x, then plus outside the bracket, plus d, and we saw that d was the offset. But what if we went inside the bracket and put our plus c? Let's go back to our modified graph, the red graph. We have sine x. Then we say plus 1. What's going to happen? Let's see. Now notice that here The original graph, y equals sine x, started at 0. It cuts at x equals 0, at y equals 0. Right? It cuts the x-axis at 0. But when we said plus 1, it cut the x-axis at negative 1. This is sine x plus 1. Suppose we had said minus 1. Minus 1. What would happen? It cut at 1. So here, when you say in the bracket, you're going to find the sign of x plus 1. There is a shift to the left, one place. When you say sign of x minus 1, there is a shift to the right, one place. Right? Suppose we had said minus 2. Minus 2. It shifted 2 places. So basically, what happened? Sine x. Then when you say sine of x plus 1, there's a shift 1 place to the left. And when you say sine of x minus 1, there's a shift 1 place to the right. So here, that's a phase shift. A phase shift of 1.5. We can see that C is a phase shift. So here, C is equal to the phase shift. In this case, it's 1.5. So that's what we have for question 4A.